Memory. Basic questions we're going to be looking at in this lecture. What are the basic processes of human memory? What is the role of attention in memory? Does everything get into memory the same way? What are sensory and short-term or working memory? And then how is information stored in long-term memory? So that's what we're doing today. So here's some questions for you. Why is the sky blue? What's your earliest memory? Can you explain how to ride a bike? So let's start with the first one. Why is the sky blue? Now, if you remember what we covered in the chapter on sensation perception, we talked about this a little bit, and you might have acquired some facts about the world that you hadn't known before. Add it to the list of thousands, if not millions, of bits of information that you have, sort of abstract knowledge about the world that you've acquired over the course of your lifespan. So why is the sky blue? Well, if you recall, we have cones in our retina that are specifically designed to respond to light of different wavelengths. And light enters the heavens through our atmosphere from the sun, and it's scattered around by molecules and dust particles and so forth in the atmosphere, and then some of that light impinges on our retina, and we perceive the sky is blue if we're looking up at the sky because the short wavelength light is being processed by our retina and then ultimately in our brain. So we perceive the sky to be blue because of primarily the wavelength of the light. So hue is something that's determined by wavelength. So that's some basic abstract knowledge, some facts about the world. Another abstract fact about the world is that if I ask you how many sides does a triangle have, what would you say? Well, you'd probably say three. If I ask you, do you remember when you learned that a triangle had three sides, then you probably wouldn't be able to retrieve or recall the very date and the time and the day and what was happening during that day and perhaps other details about that day. And so what I'm going to transition to question two. What's your earliest memory? Some of you might have memories that go way back. I think the research indicates that most people don't have really well-formed autobiographical memories or episodic memories prior to age 5, even though some people claim that they have these very vivid memories, and they might. In advance of age 5, usually we're not, most people aren't able to retrieve these vivid and accurate memories prior to age 5. Thereafter, we can form pretty robust recollections of that period of our life and then onward. So if I asked you if I went to the high school in the United States, usually there's a big dance and a big event at the end of high school known as the senior prom. Some of you attended that senior prom, and if I ask you, well, what were you wearing that night and what happened that night, what night was it, what date, you might be able to retrieve that information, even though it might have been quite some time. So what we're talking about here is a different kind of memory. This is known as autobiographical memory or episodic memory. Basically, it's our ability to recall events because they're sort of etched in time. There's particular moments in our lives that sort of are marked out or stand out from other events because of their significance. And if I ask you, what'd you do the day before your senior prom, or what'd you do the day after, or what'd you wear before or after, you probably wouldn't be able to recall, but it's that particular day that you do recall. So this is drawing on a different kind of memory system than the kind of system that is functioning when I ask you to recall some abstract fact about the world, as I did in the first question. And then this last question, can you explain how to ride a bike? This is dealing with yet another kind of memory known as procedural memory. That is, we have memories of, how to operate a vehicle, how to ride a bike, how to tie your shoes, and so forth. And these are things that require some sort of motor behavior, a memory system that guides motor behavior. So my point in asking you these three questions and starting off the section on memory this way is just to make the point that memory is not this monolithic thing. It's not just one thing, but rather it's many things. And there's some really interesting research looking at different memory systems that support these different kinds of memory. Because you could have deficits in autobiographical memory and be fine with your semantic memory, which is your memory about abstract facts about the world and so forth. So people could be impaired or enhanced in one area or the other. So scientists have to look at and say, okay, what parts of the brain are supporting, and what aspects of our sensory apparatus, for example, are supporting the formation of these kind of memories, and what's getting in the way of retrieval in some cases. All right, so memory is a multi dimensional phenomena. It's not just one thing; it's many things. All right, so we're going to be looking at memory, basic processes, how stuff gets in, and then how it's stored in this lecture. So here's some basic processes underpinning memory. So stuff's got to get into memory, so we want to know how stuff get in, how is it maintained, how is it stored, and then how do we get it back out. So retrieval will be the topic of the second lecture. We're going to be looking at how stuff gets in and how it's stored a bit in this lecture. So let's look at let's look at this sort of a metaphor, an analog, and a good analog is the computer. If you want to create a document, for example, a written document, what do you got to do? Well, in a computer, you got to encode the information, and so that's what you do when you type on the keyboard. You're encoding that information into the document, and then you're working with that document on your desktop. So or your laptop, whatever it is, whatever kind of machine you're using. So there's a kind of storage that's happening there, known as random access memory on the computer, or in the human case, it's working memory or short-term memory, where you're storing some information, you're deleting it, you're moving images around, you might be working with sound files, all on your sort of your desktop. And then there's longer-term storage, where that stuff's committed to long-term memory, or in the case of the computer, it's committed to a hard drive, so you got to name the file. And then suppose you want to get that file back, you want to reopen it, well, that's retrieval. So human memory also has processes that are analogous to the way that you create a document, you store a document, you retrieve a document in a computer. And these processes are encoding, storage, and retrieval. So we get stuff in, we store it, and then we get it back out. All right, so we're going to look at encoding first, getting information into memory. So it really starts with paying attention. This is why it's a challenge for teachers to, in a typical 80-minute course or a 50-minute course or whatever, to really try to engage students and maintain their attention. Because if people aren't paying attention, chances are the information isn't going to get in. So really memory begins with paying attention, which is selectively concentrating on one aspect of the environment while ignoring other things. So we can't pay attention to everything. If we tried, we would go insane. So really, when we pay attention, we're selectively choosing, we're attending this to one thing as opposed to another in our environment. So there's been some interesting studies that really support the relation between attention and memory. So Colin Cherry, one of the early experimentalists in cognitive psychology, which really, this is the broad area of psychology that this sort of research falls into, cognitive psychology. Well, what Colin Cherry did was he had his research participants listen to two messages coming into the right side and the left side. So you had one bit of information coming into one ear and another bit of information coming into the other ear. And then the research participants were asked to focus on one message only. So attend to, for example, the message that's entering in through the right ear. The results were that subjects perceived nearly nothing from the unattended messages. So this is interesting. That is, we can have two simultaneous streams of information entering into our auditory apparatus, and it's the one that we're paying attention to that is retained. That doesn't mean that the information coming into the left ear wasn't actually coming in. It's just that we weren't paying attention to it. Thus, it's as if practically it never happened. So, take home point here is that memory begins with attention. Must be paying attention. All right, so does stuff get in the same way? No, there's different levels of processing. So, think of yourself as an information processor. You're processing sensory information, you're processing all kinds of different social information and so forth. Does all that information get in the same way? Do you remember all of it? Do you remember some of it? And the answer is no. The extent to which you remember some as opposed to other depends in part on the level of processing. So Craik and Lockhart did some interesting research that demonstrated that we process information at different levels. That is going from really kind of shallow and quite possibly ineffective processing. Ineffective meaning that you're probably not going to be able to remember information much that you've processed at that kind of shallow level, to intermediate and then the deep levels. So the retrieval quality of retrieval varies as a function of the level of processing. And so to illustrate, we're going to do a little memory task, and then we're going to process it at 3 different levels. So this word that you see here in quotes, take a look at it. Could be that it's a novel stimulus for you. It could be that you've never seen this word before in your life. And usually when I teach this class face to face, sometimes 280 students, I ask them, have you seen this word? Are you familiar with this word? And invariably, no one is familiar with it. All right, so presuming that's the case here, we're going to process, we're going to assume that this is a novel bit of information, and we're going to process it at 3 different levels: shallow, intermediate, and deep. All right, so the shallowest is the processing that information at the structural level. So that is when we attend to its physical appearance. So let's take a look at that word. It's IATROGENIC. So if you look at it and you kind of parse it in terms of the letters, you're processing it at the structural level, which is the shallowest. And then let's process it at the phonemic level. That's when we attend to the sound of the word, and then that's processing it at the intermediate level. So let's say this word together. I'll pronounce it for you. It's iatrogenic. Now let's all say it together so we can all process it at the phonemic level. Okay, 1, 2, 3, iatrogenic. So now you've processed it at the phonemic level. Let's process it at the deepest level. That would be at the semantic level. Semantic level processing attaches meaning to the word. So this is why the cognitive psychologists tell us that when, as learners, the more meaningful we can make the content that we're learning to us, the more likely it is that we're going to be able to recall it later on. So meaning matters very much. So let's process iatrogenic at the semantic level. All right, so did you know that well-meaning healthcare providers, whether they're mental health or physical health care providers, make mistakes and unintentionally do harm, even though they've sworn not to, at least in the medical case, the Hippocratic Oath shall do no harm to patients. But this is happening fairly routinely. Medical mistakes are costing people their lives. And there's infections and therefore unintended consequences of possibly mistakes made by otherwise well-meaning healthcare providers. So really, that's what iatrogenic means. Some diseases are introduced iatrogenically. That is a medical or psychological disorder caused by the diagnosis, manner, or treatment of a physician or other provider. So we've processed iatrogenic at the semantic level because now we've attached meaning for it. So if you think about that and possibly consider a personal example, maybe you know somebody, or maybe even you yourself suffered at the hands of a healthcare provider, and this was unintentionally caused suffering, but yet it is the fact that you've suffered. If you can think of a personal example of that, chances are you're going to remember this word, iatrogenic, and its meaning. So the take-home point here is that not all information is processed at the same level. and that level matters with respect to retention and retrieval. So the deeper the processing, the longer lasting the memory code. So if you make things meaningful in your classes, chances are you're going to remember that information more effectively. All right, so concept check here. Which strategy would likely lead to better recall of the word iatrogenic? A, writing it down. B, using it as a rhyme in a poem. C, using it to describe what happened to a patient. Answer is C. How come? Well, let's look at level of processing. What level of processing is A? Is that structural, phonemic, or semantic? Answer is structural. What level of processing is B? Using it as a rhyme in a poem. That is phonemic, because when you're rhyming, you're focusing on the sound of words. What level of processing is C? That is, you're looking into your past history and maybe describing a personal example of what happened to you as a patient, to somebody else you know as a patient, or maybe some abstract person, just as a case, an example that you're developing just to enhance your recall of the word. So that would be processing it at the semantic level. All right, so let's look at storage now. Maintaining information in memory. So we're going to be looking at very quickly, briefly, at three different stores of memory. So we've got sensory memory, short-term memory, and long-term memory. So we'll look at sensory memory first. So in the United States, we have this big event, as the 4th of July, Independence Day. And maybe as a kid, you had the opportunity to light a sparkler and see fireworks and stuff like that. Well, when you move a sparkler around and it makes what appears to be like a figure eight, that light that sort of is retained, that you can do fun things with. When you move those lights around very quickly, it'll make forms or shapes in the air. My question to you is if you make a figure eight with a sparkler and it's dark out, is that figure eight that you're observing in the air actually a figure eight, or is it just a sort of an artifact of perception? The answer is B. It's not really there. It's just you're perceiving it as a figure eight, and you perceive that because of the functioning of your sensory memory. That is, sensory memory retains sensory information, just for a very a brief period of time. So about a quarter second, you're able to retain that information in sensory memory. So that's why you see sort of the continuity of the figure eight of the light when actually it's not really there. So we have sensory memory in order for us to kind of be able to hold that information for that amount of time that it takes us to sort of either consciously or unconsciously decide how to respond to it. So it's a little buffer to retain sensory information. All right, so moving on to short-term memory. So short-term memory was initially conceived as a simple rehearsal buffer. And this is back when people were just sort of working on trying to understand memory. So the idea was that short-term memory was a space that we use to repeat information such that we might move it into long-term memory. So some of that early research looked at the limitations and the capacities and was primarily descriptive. So limited duration, about 20 seconds without rehearsal. So usually when you're trying to remember something, you rehearse it. That is, you're trying to remember a phone number or something like that. You'll rehearse it. Without rehearsal, it will evaporate. 20 seconds max. And then there's George Miller's magical number 7 plus or minus 2. So think of information as entering into your into your awareness, your consciousness, as sort of a stream. It's a linear stream. We can parse it into bits. So what Miller suggested is that most people can remember somewhere between 7 plus or minus 2, so that's between 5 and 9 bits of information. max. So if you think of a phone number as having 7 bits of information in the United States, we have a prefix and then a three number prefix and then a 4-digit number that follows that. So most phone numbers are local phone numbers are 7 digits. More than that, we run into trouble. So limited capacity, about 7, anywhere, typically between 5 and 9. Recent research has kind of reduced that. I don't believe it's mentioned in our text, but some more current research has kind of moved it down. So maybe instead of plus or minus 7 plus or minus 2, maybe it's more like 4 plus or minus 1. So somewhere between 3 and 5. All right, so to illustrate this, I want you to engage in a memory task. And so what I'm going to do is read you a list of items, and your mission is to recall these items. All right, so without writing anything down, that would be cheating. I'm going to read you this list of items, and then thereafter I'll ask you to write as many of them down as you can. And then we'll see how you do on this memory task. Okay, so here we go. I'm going to read you the list. Apples, ketchup, milk, ice cream, cereal, sugar, carrots, hot dogs, chips, cookies, Limburger, eggs, flour, bacon, ham, mustard, bread, pickles, spaghetti sauce, pizza, beer. All right, so what I'd like you to do is pause this video and then write as many of those down as you can. And do that now. All right, so assuming you're back, I'm going to read the list for you, and you're just going to count up how many of these that you remembered. All right, so here's the list again. Apples, ketchup, milk, ice cream, cereal, sugar, carrots, hot dogs, chips, cookies, Limburger, eggs, flour, bacon, ham, mustard, bread, pickles, spaghetti sauce, pizza, beer. All right, so presumably when you were listening to this list, initially I had prompted you that this would be a memory task and that you would be hearing a list and that your mission would be to remember as many of these words as possible. So as if you're a conscientious student, which I hope you are, when I started reading the list, you began to attend to the sound of my voice listing these words, and maybe you began to rehearse those words because you knew it was a memory task. And then at some point, you started to have a little bit of trouble remembering the words, and then for some of you, unless you have phenomenal memories, and some people do, you sort of kind of bottomed out. And then maybe you remembered the couple of words at the end of the list, since those were most recent. Maybe you were able to remember the words at the beginning of the list, since those were the first words or the primary words that I read. So there were a lot of different studies on this phenomenon of short-term memory that identified different limitations and capacities and effects of memory. So what we're looking at here is probably what would describe the outcome of this memory task for most of you. So we're going to look at the blue line here. And what we're looking at here is a graph that lists position of the bit of information in the original list. So down here we have word 1, word 2, word 3, and so forth. And then the proportion of correct recall. That is, how many people wrote down, for example, the first word in the list was apples. And it doesn't really matter what order you wrote them down. As long as you have that word in your list, it counts as a correct recall. So what we usually see is this, like most people remember the first word and then pretty rapidly um, the proportion correct um, decreases, it kind of bottoms out, and then we see near the end of the list recall improving. So this is known as the serial position curve, and it's illustrating this serial position effect. And all it is that people remember words presented primarily, that is, earlier in the information stream, and at the end, and pretty much everything in the middle um, is difficult to retrieve, poor performance. So you see this kind of U function when it comes to recall. And it kind of makes sense given what we know about the limited capacity. That is, I mean, somewhere around, Miller said somewhere around 5 to 7 bits of information, or excuse me, it's somewhere between 7 plus or minus 2 kind of is the capacity of most people to maintain information, bits of information in short-term memory without losing it. And I wanted to note something else, that is, I read the word Limburger to you, and my guess is that, and I see this in class, that there's and that was the 11th word in the list, so that was somewhere around right in the middle of the list for us, that there was kind of a spike here in recall, and we'll get to that a bit later, but you know, I just wanted to ask now, or just present this question, something to consider, is that why do you suppose you see this primacy effect, this recency effect, and then everything else is in the middle is kind of you know, difficult to retrieve, except that one word, Limburger. So we'll get back to that in a bit. All right, so that's a serial position effect. So there's certainly limitations and so forth attached to short-term memory. Doesn't mean that we can't execute strategies to overcome some of these limits. So there's certain memory enhancing strategies that can be effective. So mnemonics is our one form of strategy, that is, please excuse my dear Aunt Sally, for example, is a mnemonic for the order of operations of mathematical operations, parentheses, exponents, multiplication, division, addition, subtraction, and then Roy G. Biv. Those are the colors of the light spectrum. So there's these mnemonics that take information that is complex, and it kind of reduces that information into sort of a memorable memorable chunk, I guess. Elaboration is another strategy. So that is, you attend carefully to that which you want to remember, and you, for example, some of you have been to maybe an event, and you're introduced to somebody, and then, you know, 1 second later, you see that person again, or 5 seconds, 10 seconds, and you can't remember their name, even though you just introduced yourself to them and them to you. So it's a little bit awkward in those social situations where literally you just met somebody and you can't remember their name. So the idea was, when you elaborate, you make the information, the name in this case, more meaningful. Maybe you attach an image to that person's name. So some people use imagery. They imagine what animal the person looks like, or something like that. Creating examples for classes. When I teach, I try to give lots of examples. And what this is doing is helping students elaborate on that information. That is, give concrete examples to maybe abstract concepts or terms, encouraging students to come up with personal, meaningful examples. So this is essentially working with the information. And when you work with that information, you make it meaningful. You're elaborating on it. And so what that does is enhance the likelihood of recall. And rehearsal is also a way to overcome limits. So certainly we can go over information over and over again, and then that's going to increase the likelihood of moving at least some of it into long-term memory. All right, so elaborate. I've got this deep processing. So as students, sometimes it's difficult in some classes to connect and engage with the material. I certainly don't expect everything in intro psych to float everybody's boat. So that's where the work comes, both for me as an instructor and as for the students, to try to make this stuff. Because, not to be honest with you, not all of it is completely and utterly riveting for me either. I'm interested in it all, but some stuff I like more than others. So it becomes a task. If the end product that we both are shooting for is learning, then the more meaningful I can make the material for you, even if it's kind of dry. The more meaningful you can make it for yourself, and that's where the work comes in. You got to work at it sometimes to make it meaningful if you need to learn it. If you do that by coming up with personally relevant examples and so forth, then chances are you're going to recall more effectively that information. All right, so now I'm going to tweak our short-term memory a bit, and I'm going to refer to it as working memory, because it's really more than just a simple rehearsal buffer, as it was initially thought to be. Alan Baddeley, for example, his research shows that short-term memory is much more complex. It does a whole lot more than the initial thinkers were believing it did. So I'm going to go over Baddeley's a model of working memory. So there's 4 components, and we're just talking about the complexities, the functions, the complex functionality of working memory. And you can think of this as the random access memory on your desktop computer, your laptop. That is, that random access memory functions much like working memory does. Random access memory supports all kinds of different things. So on a desktop or a laptop, you can work with images, you can work with audio files, you can integrate information into a video or a Word document or something like that, a presentation that has audio, visual, and text. You can store it, you can retrieve it, so you can do a lot with random access memory. Likewise, you can do a lot with working memory. So we're going to look at these 4 components. So let's look at the phonological rehearsal loop, visuospatial sketchpad, executive control system, and episodic buffer. All right, so the phonological rehearsal loop is used to temporarily rehearse verbal information. So if you're sitting in a classroom and there's lecture, you're processing auditory information, or you're talking to a friend and they're telling you a story and you remember it. You're processing that information in your working memory. So you're temporarily rehearsing it, and that's the role of the rehearsal loop. The visuospatial sketchpad is used to hold and manipulate visual images. So, for example, if you're in a city and you ask directions, and maybe you've been to that part of town before, you might try to imagine, or the person is giving you landmarks and that sort of thing. You're using visual memory to find your way. Also, when you're doing different tasks, because sometimes like telling a story or something like that, you might be using visual images and that sort of thing to sort of storyboard your story for somebody. You're describing scenes and that sort of thing. Maybe something just happened to you, and it's very vivid in your mind what happened, visually. Executive control system. This is absolutely critical. The proper functioning of this is critical for controlling attention, and pulling out of our environment, our complex environment, that which we need to attend to. So in some people with attention deficit disorder, this executive control system is malfunctioning, so they really can't, or have very little control over what they attend to. That's why there's some learning differences in people that have problems with their executive control system as compared to people who don't. So this flow of information into short-term memory or working memory and then into long-term memory has to be managed. And then particularly when we're problem solving and decision making, there's multiple bits of information that need to be sorted through and organized so that we can come up with solutions. So that's the role of the executive control system. And then there's the episodic buffer. Storage space used to integrate the work of different components. So we have all these different kinds of information, visual, auditory, and so forth, that we're working with. And then that needs to be integrated and then organized and then moved into long-term memory. So that's the role of the episodic buffer. You can think of it as that part of your working memory that is similar to if you're putting together let's say a PowerPoint production or a presentation on a computer that involves text information. It involves images. It involves possibly sound files. So taking all that information, organizing it, and then when you save that as make a permanent file out of it, commit it to your hard drive. That's supported by the episodic buffer. So working memory is capable of a number of different functions, and it's crucial for us and our normal functioning in everyday life. All right, so let's look at long-term memory just really quickly. So there's a video that I've included under the supplementary websites of a guy that he's a memory savant, just like if you remember Alonzo Clemens from the chapter on psychobiology, who could make these incredible clay sculptures, just immediately whip these beautiful sculptures out just by looking at an animal. So he was an artistic savant. So this guy, Kim Peek, that you'll see in this short video, is a memory savant. He's got this incredible memory that really makes you think about what is going on in this guy's brain, and it's supported by his sensory apparatus, his visual system, and so forth, that makes it possible for him to read a book and then remember every single word, and not only that, where the word is in the book. And he can do this for thousands and thousands of different types of documents and books and so forth. So take a minute, watch that, and come back. All right, so long-term memory, unlimited, potentially unlimited capacity store that can hold information over lengthy periods of time. All right, so what's going on? Well, how is that knowledge stored or represented and organized in memory? So again, we're just being very kind of superficial in our treatment of this stuff. There's a lot, literally thousands of studies that have covered this, and there's a whole lot more to dig into the complexities of this. But one of the things that I wanted to mention with respect to long-term memory storage is how that information is represented and organized, such that we can retrieve it. So what I'd like you to do is picture the perfect vacation spot in your mind's eye. Maybe you've been to a place, and that place is in your mind the perfect place to go on a holiday. So if you've got that image in your mind, I'm going to show you the image that I routinely get when I Google perfect vacation spot. Usually it's something like that. And boy, does that look nice, particularly if you're in the middle of winter in New England. So I don't know if that's the perfect vacation spot that you had in your mind's eye, but generally we're able to give ourselves a prompt or be prompted to recall some event or some place and that sort of thing, and we can draw up in our recollection, in our mind's eye, maybe what we believe to be a pretty accurate recollection of that place or that event or that person, that sort of thing. So how are we able to do that? Well, information that we've acquired, knowledge that we've acquired through experience is stored in the form of schemas. So these you can think of as these clusters, the organized clusters of information or knowledge that's been acquired through our experience in the world. Um, and the presence is kind of an abstract concept. So some of the research that has been done on this has identified the presence of these schemas, um, namely by showing experimentally that when given recall tasks, people tend to recall information better that's consistent with our schemas. So all of us have schemas for various things and experiences. So you might have a schema. For example, you might have a favorite restaurant that you go to, and if I ask you to sort of imagine that restaurant in your mind's eye, and you can pull it up, and you can describe that place probably with what you feel to be a pretty high degree of accuracy. So you can take yourself there in your mind and imagine what's on the wall, what happens when you walk in, the smells, the sounds, what the menu looks like, what the food's going to look like when it arrives, maybe people that you know that hang out there, maybe the staff that work there. So you've got a schema for that restaurant. Well, we have schemas for all kinds of different things. Schemas aid recall. They aid recall. It's an organized cluster of information based on knowledge and based on your experience in those situations and with that information. So, likewise, we sometimes remember information that's inconsistent with our schemas. That is, it bumps up against what we know to what we believe to be pretty true based on our memory. So I read you a list of words a while back in this lecture, and if you were to qualify the nature of that list, what would you call it? Well, it was a bunch of different food items, right? So you might think, okay, so that's a grocery list. That's something that you might bring with you to the store when you're shopping for food. Well, one of those words that I read in that list, and there was 21 words in the list, and this is uh, an actual serial position curve that I did in a class with that same list, and reliably I know this to be true. Limburger always stands out, and it's because most people don't know what Limburger is. It's a novel stimulus among the other more typical stimulus, so it stands out. If I said Volkswagen, it probably would have had the same effect, but this is the Limburger effect, I call it. Limburger is actually kind of a cheese. It's a very, very smelly cheese that most people in the United States have never tried, I would have to say. But it's novel. It's inconsistent with the schema for grocery list. So it's inconsistent with cookies and eggs and flour and bacon, that sort of. It just stands out. So this is an example of how our schema for grocery list or words that kind of hang together bump up against a word that is inconsistent with those others. All right. And then the last thing I wanted to mention in terms of storage is semantic networks. So I want you to complete this phrase, bread and. Some of you probably thought of the word butter. So bread and butter kind of go together. It's kind of an old way. I don't know how many people put butter on their bread anymore, but certainly on toast. So bread and butter kind of go together. And this is kind of like a word association game. If I say a particular word, then and I ask you to list the first 5 words that come to your head, then there might be some similarities between what we see in terms of the first words that are coming to people's heads. So there's certain things that are associated with other things. Well, think of your memory, in your long-term memory. There's all kinds of different types of information, and it's not that each of these bits of information is in isolation from the other bits of information, but rather that information is stored in complex networks, both physically, that is in the brain stuff, neurons and that sort of thing, but also conceptually. So think of semantic networks as consisting of a network of associations among concepts. So, for example, if I say the word fire engine, that's kind of the key word or the critical item. And then I asked you to list all the sort of the words that come to mind. And this is what research on semantic networks has done. So the critical item would be fire engine, and then we have words that kind of occur more readily than others. So the words that occur readily are red and orange and ambulance and truck and fire and house. So those come up pretty routinely right away. And then there's this spreading out of other of the network to other concepts or words that are associated with fire engine but more distantly associated. So now we have, way out here we have pears. Where does that come? Well, pears are kind of fruit that are associated with apples. Apples are red. So this semantic network kind of spreads out until you have, clouds and sunsets and stuff like that. Words that you wouldn't think, or concepts that you wouldn't think are remotely associated with fire engine. But yet, in studies that have been done on these semantic networks, people are mentioning those things. They're pretty far out there. They're associated, but associated in kind of a loose way. All right, so I'm going to give you another list of words to kind of illustrate the presence of these semantic networks, and also kind of to segue to our next topic, that is retrieval, which we'll cover in the next lecture. So I'm going to read you this list, and this is a memory task, so you're going to be asked to recall these words later on. All right, so don't write these down because this is a real recall task. So here are the words: rest, slumber, nap, crash, bed, mattress, awake, tired, dream, wake, snooze, REM, snore, drowsy. All right, pause this lecture and this video and write down as many of those words as you can from recall. All right, so I'm assuming that you're back and you've written down those words. And I have one question for you. How many of you have the word sleep in your list? And there's no way I can know because this is a video lecture, but I'm going to guess that most of you wrote down the word sleep. Sleep was not in the original list. In the original list, I had rest, slumber, nap, crash, bed, mattress, awake, tired, dream, wake, snooze, REM, snore, and drowsy. Sleep was not in the list. However, when I do this in a class, there's always a good fraction of the class, I would say the majority, if not half, have the word sleep. And then they're pretty convinced that I said sleep, but I didn't. So what this illustrates is a couple of things. One is the presence of a semantic network. So I read you a list of words that were associated with the word sleep. So you mistakenly recalled that I had mentioned the word sleep. So we have a semantic network for pretty much all the kinds of information that we have in our long-term memory. Interrelated concepts. The other thing that this exercise illustrates is how easy it is to create so-called false memories. That is, if I asked you how confident you were that I had mentioned sleep, some of you might have said, I am certain, I'm so certain I'd be willing to bet money that you said sleep. There's no way that you didn't say sleep. The fact is that I didn't. So this gets into issues related to accuracy of recall. So that's what we're going to be looking at in the next lecture, at least in part, is the retrieval process and then how things go away in the case of forgetting. So here are the learning objectives. Take a look at these. Make sure you study the information that's relevant to these learning objectives.